Hello, welcome everyone. This video is the first of a series of videos representing core subject matters of the course Computer Simulation and Modeling. I am MD Tanvir Hussain, Assistant Professor, Computer Science and Engineering Department, University of Rajshahi, going to be your teacher throughout the course. Our interactive real-time class system will be held at the Big Blue Button server setup of University of Rajshahi. I am going to provide you the links throughout the course, so don't worry about it now. One or more videos of this course or of this series are going to help us throughout those classes, meaning that I am going to prepare the core contents of the slides or main discussion topics so that we can skip those theoretical discussions on those interactive classes, and I'm going to play the videos of this series, and then whenever you have got questions you are going to ask me, and I'm going to pause this video on that interactive session, and then we are going to solve the questions, and then we are going to play the video again. So it will help us to communicate more interactively and taking away the theoretical discussion part in a separate static video that you can refer to anytime. Okay, so the interactive class links, books and many other resources will be shared over the pre-configured Google Classroom. So you have to head over there to get the links and all the other resources and other small real-time resources, or whenever you do need to refer to something during our interactive classes, I am going to share them on that platform. We're going to discuss that platform more in a later video or directly in one of the first interactive classes. So what you have to do is you have to request everyone associated with this course to get attached with these platforms, meaning you have to tell your friend, those who don't know or those who are still unaware that we are starting interactive classes, ask them to join over Google Classroom or ask them to participate over the interactive classes system. So those interactive sessions are going to be recorded too. They are going to be hosted there, and if I plan, I may also take those videos down and upload them to YouTube, maybe, but I haven't decided yet. So let's continue. So your first task is to help everyone get together on these platforms that you are going to interact on. Okay, so share the YouTube video links, interactive class link and Google Classroom code and such with all of your classmates or associated people with this course. Okay, and for the laboratory experiments, there is going to be a separate series of videos for those only. Okay, so I'm going to create them separately before alongside this theoretical materials, so you don't have to worry about that, and when the need comes I'm going to share them with you during the theoretical classes. Let's say we come across something practical during our theoretical discussion, so I am going to create that specific need if we needed a video for the lab, and I'm going to share it with you. So let's start today's class. Okay, I'm going to discuss the very basics of the course, including the preferred books, the programming languages that we are going to use, and all other necessary things. So let's start. Okay, so the course code of this course is 4131 and the practical part is 4132, and the name of the course is Computer Simulation Modeling, as we have discussed. The main books that we are going to prefer or going to follow in this course is System Simulation with the Digital Computer. Is a very old book but the theoretical parts are very basic and in standard ones, so we can get started easily. We are not going to stick on the curriculum of a book or the topics of a book strictly. We are going to jump from book to book or even internet resources, so keep up with those throughout the course. And another book that is most important is computer graphics. Okay, so let me discuss something before we're going into our next slide. um, there are some prerequisites of this course because it's a bit of implementation related course, because we need to simulate something, we need to model something, we need to test how our models behave in simulations. So theoretical parts, our underlying core concepts are discussed more in detail in previous courses that you may have faced. Like you should have already completed this course, computer graphics, and a lot of the underlying theoretical concepts are going to be utilized in this course, especially in the modeling part of the course. Okay, and another one prerequisite course is numerical methods. Okay, because there are some interpolation topics, or like how we can draw the edges of a specific model and how smoothly can we do it, and like those and things and many other things. So that is also a prerequisite course. And okay, so let's continue with the current slide. There is another book that we are going to follow in very specific parts of the course, that is discrete event system simulation, and all the authors names and the publisher names are included here, you can see. And so for the practical parts, we are going to use C and C++ for the very basic core numerical simulations. We are not going to use SimScript or Model Sim, because these are already a lot backdated software, or even as not currently widely used. So we're going to use Python. For we can use matplotlib, a specific library, or even we can use PySim and many other libraries with Python, and to do different kind of simulations, real world tasks that can help us easily understand or even see the effects of modeling and simulation and such. And also alongside this, we are going to use real world modeling software, Blender. It's widely used along various industries. It's a open source software, but very powerful. A bit hard to get started with, but I'm going to give you resources that certainly helps to get started easily. YouTube resources or different courses from Udemy or other platforms. Alongside this, we are going to use sometimes some online applications, online softwares, and also we may use slightly MATLAB, maybe, but I'm not sure, because I have planned this for previous courses in the older years when you had to take this course. I got used with this software, but I'm moving from this one to Python for ease of use and ease of installation and such, but we will see more. Okay, so let's go along. Now this is a video. It's a video about simulation and modeling, so let's play it.
Imagine a world of your own creation.
Okay, it's a YouTube video that you can get via searching on YouTube, Modeling and Simulation 101. just type that modeling and simulation 101, you will get to this video. But I have included this video alongside this course because it explains very core concepts and it's very interesting. Let's see.
Where you can see what doesn't yet exist, where time and space are under your command. A world where you can do anything, and there are no mistakes or wrong answers, where the only limits are those of your imagination.
So you see, imagination, whatever you can imagine you can implement, because we are going to see the theoretical concepts after a bit, before seeing the real world implementations, real world applications. Okay,
This is the world of modeling and simulation. Hi, my name is David, and I'm here to take you on a journey through that world. Modeling and simulation, or M&S, are ways of understanding the world around us through creativity and imagination. But what does that really mean? There are three main types of models: physical, mathematical, and process.
so you can see there are mainly three types of models: physical model, mathematical model, and process model. What are they? He is going to explain. I am going to talk later.
A physical model is one whose physical characteristics resemble those of the item being modeled. In other words, it looks or feels like the real thing. It could be a toy plane, a statue, or the blueprints for a house.
So physical model is actually the physical representation of any object that is going to be there in a simulation. Okay, so if we were modeling a computer, your monitor will be a model, your keyboard will be a model, your CPU will be a model. So I'm talking about a whole computer set. So those are models, and whole thing is working together to simulate a computer system. Yeah, that's an example.
A mathematical model is one that uses mathematical symbols and relationships to describe something. You've all done graphs in math class, but it could also be a chemical formula or your baseball stats. The third type of model is the process model. It describes the steps we need to follow to get something done. This could be as simple as a to-do list, or for the computer types out there, a flowchart.
So the mathematical model and physical model are kind of similar. I mean, not similar. Mathematical model are just equation that calculates something based on other variables, like y is equal to a function of x. So if you change x, the y will be changed. So that's kind of thing is mathematical model. Okay, we might design something, we might simulate something based on the internal mathematical equations. So for those systems we can use mathematical models. And for process model, we can say it's an algorithm, we can say it's a flowchart with steps to complete a task, or steps to complete a goal, or reach a goal, a target. So process model, mathematical model, and physical model, if we utilize all these three types of models, we can simulate, we can represent almost anything. He is going to say that now.
With these three types of models, you can model basically anything: equipment, systems, environments, people, even behaviors. And they can be so cool to build. At McKinley Tech High School in Washington, D.C., students learn computer science, 3D modeling, and programming. So Rick, what I've seen here is pretty amazing, but it looks kind of complicated to me. So how do I begin to start learning about all of this?
Actually, it's not that complicated. What you start off with is 3D modeling, learning how to make different spheres and things, and then just building upon that. The program called Maya, which we use, is pretty advanced. It's college level.
So they're using Maya. Maya is also very advanced, as he said, but Blender is entry level, beginner friendly, little, but not the interface. You might get overwhelmed, but don't be. You need to memorize, you need to think about some keyboard shortcuts or steps that actually match well with the 3D environment. So don't worry about that. Maya is going to be out of our course curriculum because it's a bit too advanced and it requires very high configuration of computers. So we're going to use Blender instead.
but we found that children as young as 12 years old can learn.
Students really get into their projects. While we were there, they showed us how they made their models lip sync.
Well, right now, this is the program Rigman. We're practicing lip syncing and facial expressions, so that way, you have experience with modeling faces for animation.
Cool.
Well, our projects are not going to be that complex, not that cool, right? Because very simple things are becomes sometimes quite hard to achieve. This is on another level, actually.
Can we see the guy talk?
Yeah.
If you're on my side of the armrest, we're not going to have problems, are we?
If you can do that, any one of you, I'd be very, very happy.
Enthusiasm is all you need to learn modeling and simulation.
So it's fun, it's interactive, and it actually opens up a lot of fields for job opportunities.
From lip syncing human figures to modeling oil rigs, students learn how to use models in real-world applications. Samantha wants to be a cartoonist. The skills she learns here will jumpstart her career.
Say I'm making like a 3D cartoon.
Okay.
And I got to make the characters. So this program will be a big help to me because when you learn how to put everything together, it's like constructing the characters, no problem.
Anyone can learn modeling and simulation. No matter what your skills are, there's a place for you. Just like there are 3 main types of models, there are 3 types of simulations.
So we are going to talk about simulations now. Because what comes first, model or simulation? Of course, models, because simulation cannot be conducted without having the objects that we are going to experiment on. So those objects are the models. So we need to create models first, need to assign them behaviors, need to assign them mathematical model characteristics internally, and then starts the simulation. So for an example, we have a plane, a straight plane, and we have a bouncing ball, rubber ball, and we put it up. We assign the rubber ball characteristics to that sphere, and we drop that sphere, giving some gravity, and it will bounce on the surface, right? So we have the ball, we have the plane, those are models. We're assigning behaviors, rubber ball behaviors to the sphere, that's mathematical model, and the steps, which is going to be given a gravity, it's going to start from this point and go to this point, like that. Those are process models, and so it's an example. So let's see the simulation, different types of simulations.
Live, virtual, and constructive. A live simulation is one that involves real people operating real systems, like practicing golf or soldiers simulating military maneuvers. A virtual simulation is where real people operate simulated systems, like flight simulators or driving simulators. Constructive simulation is where simulated people operate simulated programs. People provide the input for the situation. It could be traffic, the weather, or an explosion, and the simulation tells us what might happen. Let's take a look at the different ways simulations are used.
So there are 3 different types of simulations: live simulation, virtual simulation, and constructive simulation. As you can see, you can pull out examples. Live simulations he has already given. I am going to give another example, like a crash test of cars. There is no real accident there, but we are forcefully creating accidental situations. We are driving the car towards a pole, towards a wall, and seeing how the dummy doll that is sitting in the driver's seat becomes hurt or not, or what kind of how it gets affected to those events. And that is live simulation. You can see such videos or interesting programs over on Discovery Channel and other YouTube resources. And for virtual simulation, we have virtual reality now, right? There is so many virtual simulation going on now in that area, implementation area. And for constructive simulation, those are how the simulated models behave to other simulated events in a whole simulation system. Like for an example, in a game, in a game where there is a real living, breathing world, and have some infrastructure, and there is also some people there. Like in a game for an example, I can give you an example of a game like Grand Theft Auto. Their whole environment, there is sky, there is building, there is rivers, there are cars, and there are NPCs, human beings, or artificial human beings, right? So those are walking along the road in a given situation, and you as a gamer driving your car, in front of them they are going to jump away from your car, right? And that's a behavior, that's a simulation, right? How you can avoid. And if you have a very high speedy car, he will not be, the people will not be able to avoid, you will be crashing them over, right? That's a example of constructive simulation. Now we're going to see how simulations are used.
Programs. People relation tells us various game is simulations are used. This is Breakaway Limited, one of the world's premier creators of simulations. So Ed, we've been talking about simulations here, but you seem to call them serious games. What's that about?
Well, serious game is the serious application of video game technology in a simulation.
Breakaway creates simulations for real-world applications. One of their products, called Pulse, is a medical training simulation. Doctors are trained in a virtual environment to diagnose patients and perform surgeries. That's an example then of a virtual simulation.
Yeah.
So there's also constructive simulation. Do you make those as well?
Yeah, we have a project called Incident Commander. It's about training individuals to work together in an emergency situation.
Incident Commander is a virtual world with virtual people. By providing input to the simulation, for example, an explosion, it allows police, firefighters, and other emergency personnel to learn how to work together more effectively. All simulations, live, virtual, and constructive, are great ways for people to learn how to handle situations and become better decision makers.
Letting people make mistakes in a virtual simulation allows them to make better decisions when they go out into the real world.
Simulations also allow us to test ideas before committing to them. Making models and then seeing how they work in simulations allow us to make improvements more quickly, more safely, and for less money. Modeling and simulation is used everywhere you look, from movies to games to building cars and flying airplanes. The possibilities are endless. As we've seen, students are learning how to make their own models and simulate them to do whatever they want. The world of modeling and simulation is wide open, so no matter what your interests, there's a place for you.
Okay, that's enough for this video. In the next video I'm going to continue from this slide here. Okay, we are going to start officially start the theoretical discussions of simulation and modeling. We have studied the basics, we have got the motivation and the initial classifications of modeling and simulations, models and simulations. So that's it for now. See you in the next video. Thank you very much for watching. Goodbye.